We usually write numbers in decimal form or base 10, meaning numbers are composed using 10 different digits, 0 through 9. Sometimes, though, it's useful to write numbers hexadecimal or base 16. Now, there's 16 distinct digits can be used to form the numbers. You go 0 through 9, and then A, B, C, D, E, and F. Now, A represents 10, B represents 11, C 12, D 13, E 14, and F 15. So it goes from 0 to 15, basically, with those substitutions I just mentioned, which is a total of 16 digits. So, for example, a 3-digit decimal number might be 2B8. You see hexadecimal in various parts of computer science. Okay, A. Back there. How many 2-digit hexadecimals are there in which first digit is E or F? Explain your answer in terms of the additive principle, using either events or sets. Okay, E. And I'll write this out. E or F. Okay. So I could have, then they're saying 2-digit hexadecimals, which means I can have E1, E2, all the way up to E9. There's also, one I forgot, E0. Okay, and then I can have EA, EB, EC, ED, EF. Because again, these go up through 0 to 9 and then through F. Well, there's a total of 16 there. Because it's based upon the second digit, and it goes from 0 to 9 and then A through F. Remember, that's 16 possibilities. Now, our second one, we'll have F1, I keep forgetting the 0. F0, F1, F2, all the way up to F9. And then, of course, we'll have FA, FB, FC, FD, and F. I forgot something. A, B, C, D. I forgot the E here. I better go home, go back to bed. Okay, F, E, and FF. 10, 11, 12, 13, 14, 15, 16. Okay, 10, 11, 12, 13, 14, 15, 16. So 16 possibilities there. So through the additive principle, if I add those together, that's going to give me a total of 32 possibilities. Okay. B says, explain why your answer to the previous part is correct in terms of multiplicative principle using either events or sets. Why do both the additive and multiplicative principles give you the same answer? Okay. We got 2 digits. The first digit can be E or F. So that's 2 possibilities. From the multiplicative principle, multiplication rule, we do multiply. And this can be anything from 0 to 9 or A through F, which is a total of 16 possibilities. So again, this is 0 to 9, or it can be A through F. Well, 2 times 16 is 32. And the reason why they give you the same is because they're kind of the same principle. There's 16 possibilities here. And that includes this right here. And then, the E and F gives us 2 columns. So 2 columns times the number of possibilities. So it kind of goes hand in hand. Let's see. How many 3-digit hexadecimals start with the letters A through F and end with the numerals 0 through 9? Okay, let's think about this. 3-digit possibilities. They start with the letter A through F. Okay, well, that's 6 possibilities. A through F. And end with a numeral 0 through 9. Okay, so this last part has to be 0 through 9, so that's 10 possibilities. Now, they don't say anything about this middle, but they do imply it's a hexadecimal number, which means that it can be A through F, or it can be 0 through 9. So this is a total of 16 possibilities. What's that give us? Assuming I can do basic math, 960. Assuming no basic math mistake. Now D. How many three-digit hexadecimal numbers start with the letters A through F? So this is, the first one is A through F. That's 6 possibilities. What does this mean? How many three-digit hexadecimal start with the letters A through F or end with numeral 0 through 9 or both? What they mean by both? Now, of course, it's if I'm reading it right. That's always a big question mark. Don't assume just because I'm working a problem and I'm the instructor that I actually am interpreting it correctly. But I think what they're saying when they say are both mean that I could start with 0 through 9 and I could end with A through F. And this would still be 16 in the middle. So this one's 960, and this one would be 960. So 0, 2, 1. I think that's right. That's assuming I'm interpreting what they mean by that. That's my best guess. I'm not always good about reading items closely and understanding what the author's original intent was.